In this tutorial, we will be talking about groups selector. So as you can see, I am logged in, I have an engine loaded, so I can go to the selector top menu bar. As you know, in fullrmc, you can group atoms in groups, and we will be talking more in details about that in the groups section in here. And groups will be selected by the engine to perform moves upon those groups and to try to enhance the structure of your system. We will be talking about group moves in this section in here. So now let's focus about selectors. What you can see here in front of you in that web interface is that you have two main sections, the left part and the right part. On the right side of it, on the right part here, you have the current state of the engine. So engine selector, it's already a defined order selector, and we will discuss that. And to the top here, you have a drop-down list where you can choose a list of selectors that are predefined in fullrmc. We will start by exploring these one by one. So now I will go to the random selector. So as it names says, it's a random selector, which means it randomly selects groups of atoms from the engine, so the engine can perform moves on those groups. It's purely random. There is no parameters, there is nothing you need to do other than setting this selector. I'll go about doing that right away. Now you can see here the engine selector is a random selector. It has absolutely no parameters. But still, every selector in fullrmc can be used as is, or it can be wrapped by a recursive group selector. And a recursive group selector let the engine select the same group a recurrent number of times before it allows the selector to select another group. And this is a very important property to set when you need your engine to give a little bit more leeway and leverage for a group of atoms to find a better position for itself before moving to another group of atoms. So you would give a group of atoms a chance to improve its position before the engine go about trying to find another group in your engine and refine the position of that group. And to do so, all what you need to do is to set the recur variable here a value that is bigger than 0. So let me put here 10. I'll set this. So now the group selector is still a random selector, but it's a recursive selector with the recur variable set to 10. Override to true, refine to false, explore to false. Let me set those two to true. Set it again. Well, you can see it's a recur 10, override true, refine false, even though I set it to true, and explore to true. This is because in fullrmc you cannot set both flags to true. It's even one or another, and fullrmc chooses explore. So if I want to take out explore and set it again, now I have refine. So to see what those refine and explore parameters are, I need to go to the documentation. I need to go to selectors here, and I need to find where this recursive group selector is defined. I'm finding that, and this is the definition of a recursive group selector. And you have the explanation of those flags and variables. I am not going to be reading that for you. I'll let you explore it by yourself when you need it. So now we set the random selector. Let's go and try to find what else can we do. So a little bit more complicated selector is the weighted random selector. So this is just another random selector where the weight of selection or the likelihood of selecting a group, a user can set it by himself. So by default, the weights are set to none, which means all groups have the same weight, which is which will have this selector behave just like a normal random selector. Let's go and set it. So a weighted random selector where all the groups are weighted to 1, that's by default, the weighting by default. And when you see the weights, you have as many weights as the number of groups you have in your engine. Now, what you can do about that is to try to set different weights per groups. And the way you do that is by specifying a list of tuples, and I will be a little bit technical here. So it's a list of lists or a list of tuples where the tuples that you see here, so that's the list, this is a tuple, that's a tuple. The tuples first item is the index of the group in your system. And the second item in the tuple is the weight of the group in your system. Let's have an example. So now I want the first group in my system, this one, to be 100 times more likely to be selected comparably to all other groups. So index 0, weight 100, set, and here you have it. The weights are 100 for group 0 and all the remaining are 1. I want to add to that group index 4, I want it to be selected 50 times more than all others. But now you know how the math works. This is 50 times, this is 100 times, everything will be normalized at the end. So here you have it, and you can also set this group to be recursive, just like any other selector. I'm sorry, you can set the selector to be recursive, just like any other selector in fullrmc. Another group selector is the smart random selector. And the smart random selector is another weighted selector, another weighted random selector. But the weights of that random selector will be adjusted on the fly by fullrmc using a reinforcement machine learning algorithm implemented in fullrmc that adapt the weights of the groups by studying how those groups will likely enhance the structure of your system. So I'm not going to get into the weeds here and explain how that is done, but there are two parameters to set, the bias factor and the unbiased factor. You can read more about those in the documentation as well, and the default parameters are fine. The initial guess of the weights is all 1, so the by default weights. Let's see that. You can give it a different guess as well, just like we did before. You can say, okay, I want you to start by selecting group number 10, 5, weight of 5, and group number 11, I want to give it a weight of 7. I'll set this, and here you have it. Group number 10 and group number 11, they have two different weights as an initial guess. And remember, the weight will be changing along the way when the engine is running and fitting your system. This is a smart random selector. So the weights will end up being completely different depending on whether a group is likely to enhance your system or not. Now let's go to defined order selector. And let's not forget as well that this group selector, you can also set it as recursive. So I can put here 10 and it's a recursive group now. Now let's go to defined order selector. A defined order selector is not a random selector. It's a selector where you define the order of selection of the groups. So if you want the group number 10 to be selected first, you would put 10 here. And then you want the group number 11 to be selected second, you would be putting 11 here. And you create the groups, and now your selector will only be selecting group number 10 and 11, and in that order. It will be 10, 11, 10, 11, 10, 11. You can even give it different numbers, 100, 101, 0, and 110. You can go as much as you want. You can repeat the group number as many times as you want, 0, 0, 0, and the selection will go like such. Group number 10 selected first, then 11, then 100, then 100, then 1, then 0, then 110, then 0, 0, 0. And then let's play a little bit with this as well. Let's put recur equal to 10. And now when the engine starts working here, group number 10 will be selected first. It will be selected 10 times in a row before going to group number 11. And group 11 will be selected 10 times in a row before going to group number 100. And so on and so forth. So finally, let's go to the final group that is defined for you, which is the directional order selector. And this selector is by far one of the most interesting selectors if you are studying your system, if you are trying to modelize systems that are evolving in situ, for example. So if you're heating up your material, you expect your material to expand, and you need your simulation to reproduce that. So you need to set in place a defined order selector that allows your system to expand in space. And the way this is done, you set a center and you activate or deactivate the expand flag. So if you activate it, then the system will expand. If you deactivate it, the system will retract. And you can let fullrmc assign automatically for you the move generators for the groups. If you do so, the move generators will be a collection of a translation towards the center, and in this example it will be away from the center, using a different angle of translation in a conic angle. So you can read more about those in the documentation as well, along with a rotation of a maximum of 10 degrees. And you can set those as well. You can change with those parameters. You can play with those parameters as well. So this way, when you set the center, and you can set it the way you want, the way you think it should be. You can set it as fixed by giving the center XYZ coordinates, or you can let fullrmc define the center for you by giving it keywords like geometric here. Let me go put back the mouse. Geometric, X-rays, neutron, or other parameters that will let fullrmc calculate a weighted center for you. And this center will be calculated from all the atoms that exist in your system. So you can also make this as a recursive, or you can refine and do whatever you want to do. So this is all what it is about in the selections. I will probably now spend 2 more minutes explaining what refine and explore are. So when you create a recursive selector and you do not specify whether you want to refine or explore, every time the engine selects a group and try a move upon that group, if the move is accepted, the group of atom moves to the new position that the move generator created for it. Now, if you set refine to true, if you have refine flag to true, and recur is 10, the move will be applied upon the selected group always from the original position it had at the first time it was selected. And the best out of the 10 moves, the best of the 10 moves that are accepted will be chosen as the final accepted move. If you specify explore, the group will be exploring for 10 times, for a recur number of times. It will be creating a trajectory of positions for that group in the space. You can set it to 100 here, and you would have 100 moves for that group, regardless whether the group move enhances the structure or not. The group will keep moving in the space for 100 times, and then at the end the engine will consider the best position out of those 100 positions in the space. Maybe my wording is not well understood and I need a board to explain all of that. And you can also read more about it in the documentation, and we can discuss it offline as well.